What if time as we know it is not a fundamental aspect of reality? This question takes us on a journey into one of the most profound puzzles in both science and philosophy. While some theories propose that time began with the Big Bang, making any inquiry about a before nonsensical, much like asking what lies north of the North Pole, other models suggest a different story. These alternative ideas propose that time may have existed prior to our universe, perhaps in the form of eternal cycles or within hidden dimensions, prompting a deep exploration into the very origins of existence. The Big Bang remains the most widely accepted scientific model for the universe's origin, suggesting that everything you see around you, from the farthest stars to the atoms in your body, emerged from a point of extreme heat and density, approximately 13.8 billion years ago. Yet, this raises an unavoidable question. What existed before that singular moment? Did time itself have a beginning alongside space and matter? Or is it an eternal canvas upon which the universe was painted? For many, contemplating this is as disorienting as trying to imagine a world without any light, a conceptual challenge that pushes our understanding to its absolute limits. To help visualize the early universe, you can think of it as an expanding balloon. In the beginning, this balloon is incredibly small and dense, but as it inflates, it stretches and cools, creating the vast cosmic arena for galaxies and planets to form. However, when we trace this expansion back to its starting point, we encounter a singularity, a state where our current laws of physics completely break down. This forces us to question the very nature of space and time, especially if they both sprang into existence at that instant. While the universe's ongoing expansion serves as a constant reminder of this dynamic origin. Our perspective on this cosmic puzzle was revolutionized by Albert Einstein's theory of relativity. He demonstrated that time is not a rigid, universal constant, but is instead a flexible dimension that can be warped by gravity and velocity. For instance, in the presence of an immense gravitational field, such as the one near a black hole, time itself measurably slows down. This malleability of time opens up fascinating possibilities, including the idea that it may have a far more complex history than we assume, potentially even predating the Big Bang itself. Exploring what might have existed before the Big Bang is like trying to peer beyond a mirror that reflects only absolute darkness. The questions just continue to multiply. If there was no time, how could there even be a beginning to speak of? This leads us to another captivating mystery, the arrow of time. This concept describes why time appears to flow in only one direction, from the past toward the future. The answer seems intimately connected to entropy, the natural principle that systems tend to move from a state of order toward greater disorder, a process that seems to define our perception of time's forward march. When we shift our focus to the realm of quantum mechanics, the nature of time becomes even more strange and counterintuitive. On a subatomic scale, time can behave in ways that seem to defy conventional logic. For example, particles can exist in multiple states at once, which raises a mind-bending question. Is our experience of time as a straight, linear progression an accurate reflection of reality? It's possible that, at its most fundamental level, time is not a single line at all, but a complex labyrinth of potential pathways. Modern cosmology confronts these monumental questions by blending rigorous scientific inquiry with deep philosophical reflection. As our tools allow us to probe a universe that is constantly expanding and evolving, each new discovery compels us to revise our understanding. This isn't a new pursuit. Concepts of time have varied dramatically throughout history, from the cyclical interpretations of ancient cultures to modern theories proposing that time might simply be a construct of human consciousness, shaped by our unique experiences and beliefs. Furthermore, cutting-edge scientific experiments consistently challenge our most basic assumptions about time. From the bizarre, spooky action at a distance of quantum entanglement to the incredible precision of atomic clocks, science is always testing the limits of what we thought we knew. These investigations are more than just academic exercises. They reveal that our understanding of time is not static, but is in a constant state of evolution. This same abstract concept has also been a central theme in culture and mythology, where countless civilizations have crafted narratives to make sense of its relentless and often mysterious passage. Ultimately, the Big Bang did not just signify the birth of our universe. It also unlocked a cascade of profound questions about the nature of time itself. Through this exploration, you can begin to see that the universe and time are inextricably intertwined, and every scientific breakthrough brings us a step closer to understanding our own place within this cosmic timeline. This incredible journey through space and time has only just begun, inviting all of us to keep asking questions and to never stop exploring the great unknown. While the phrase Big Bang is familiar to almost everyone, its true meaning often gets lost. To clarify, imagine that initial moment when all space, time, and matter were compressed into a single, infinitesimally small point, a kind of cosmic seed. The Big Bang Theory is the model that describes how the universe has evolved since that decisive instant. It isn't just a story of creation, but a detailed framework explaining the universe's expansion and cooling from an unimaginably hot and compact state into the vast cosmos you see today. Imagine a moment when a cosmic egg burst open, triggering an explosion that gave birth not just to matter, but to the very flow of time itself. In this view, the Big Bang wasn't only the start of our universe, but also the dawn of time. But what evidence do we have for this? Since the 1920s, astronomers have noted that galaxies are all moving away from one another. This expansion of the universe is a cornerstone of the Big Bang Theory, suggesting that if everything is spreading apart now, it must have been incredibly close together in the past. To visualize this, think of a balloon covered in dots. As you inflate it, all the dots separate from each other, which implies everything originated from a single condensed point. This naturally leads to the question of what was happening before this expansion started. When we discuss the initial singularity of the Big Bang, we find ourselves at a crossroads where scientific inquiry meets philosophical thought. A singularity is an extraordinarily complex idea, a state where our current laws of physics simply cease to provide any answers, much like trying to understand the interior of a black hole. This initial singularity prompts some fascinating questions. What, if anything, existed prior to this point? And did time even exist before the Big Bang? Some scientific models propose that time itself did not exist before the universe began its expansion, akin to a road that simply appears out of nowhere without a starting point. Conversely, other more speculative theories suggest that time might have existed before the Big Bang, but in a form that our current instruments and understanding could never measure or comprehend. Could it be that time is merely an illusion, a framework our minds create that only functions within the context of an expanding universe? The Big Bang also forces us to consider the directionality of time, what physicists refer to as the arrow of time, which explains why it seems to flow in only one direction. The explanation may be found in entropy, a principle that describes the tendency of systems to move toward a state of greater disorder over time, much like a perfectly arranged box of blocks becomes chaotic when shaken. When we venture into the realm of quantum mechanics, the concept of time grows even more puzzling. In the quantum world, particles can exist in many states at once, which makes you wonder if time is a universal constant or if it possesses a more flexible nature. This very dilemma has captivated both scientists and philosophers, compelling them to reflect on what time truly is and what our place within it might be. As we delve into modern cosmology, we are confronted with how deeply time is connected to the expansion of the universe. Throughout history, human cultures have interpreted time in a multitude of ways, creating rich mythologies and narratives to explain its origin and nature. From ancient beliefs in cyclical time to modern theories of relativity, each civilization offers a distinct perspective that adds depth to our collective understanding. This journey into the Big Bang and the essence of time confronts us with a series of profound and intricate puzzles, where every potential answer seems to unveil even more questions. Perhaps in this relentless pursuit of knowledge, we discover the real worth of our own curiosity. The Big Bang encourages us to look beyond the immediately visible, challenging us to ask fundamental questions about the cosmos we live in and the time we perceive. Ultimately, by studying the Big Bang and its consequences for time, we are not only deciphering the secrets of the universe, but also contemplating our own existence and our role within this vast, mysterious reality. Let's revisit the initial singularity, a fascinating idea that is central to our cosmic origin story. To truly grasp what this means, we can once again imagine the entire universe as a deflated balloon, completely compressed. The singularity represents that initial point where everything we are familiar with, all matter and energy, was concentrated into an infinitesimally small point. Small, incredibly dense, and unimaginably hot space. At that exact moment, the laws of physics as we understand them break down completely. When we talk about the singularity, we are referring to an instant when time and space, as we experience them, had not yet come into being. The question of when time began is one of the most compelling enigmas humanity has ever faced. The singularity has no before or after, because there was no when. It represents a state of being that fundamentally challenges our intuition and forces us to reconsider everything we assume about the nature of time itself. The concept of an initial singularity brings up many questions, such as how everything could expand from a single point. The answer is embedded in the very nature of the Big Bang. At that first moment, the universe initiated an explosive expansion, similar to a spark igniting a fireworks factory and illuminating the entire sky. This event was an incredible eruption of energy and matter that brought forth our cosmos. As the universe expanded, it also started to cool, and this expansion involved not just matter, but the fabric of space itself. Picture dough rising in an oven. It isn't just the bread that gets bigger, but the space it occupies also stretches. In the same way, the expansion of the universe allows time to unfold, creating the sequence of events that we perceive. Yet, the singularity remains one of the greatest mysteries, challenging us to rethink our deepest concepts of time and reality. What if your conception of time's origin is fundamentally flawed? The idea of a singularity challenges conventional logic, presenting a paradox when you consider that our entire reality sprang from this incredibly dense point. It suggests that our familiar, linear perception of time might be incorrect, with some theories even proposing a cyclical nature instead of a distinct start. This reshapes the entire inquiry, leading you to ask, could there have been time before time itself began? While theoretical physics has delved into these profound questions, definitive answers are still beyond our grasp, and every advance in our cosmic knowledge seems to uncover even deeper enigmas. The initial singularity serves as a potent reminder of how limited our comprehension of the universe truly is, and how it must continually adapt. It compels you to challenge your most basic assumptions and gaze past the boundaries of current knowledge, forcing you to contemplate the true essence of reality itself. When you explore these ideas further, it becomes clear that the singularity is intimately linked to your own existence. If this single point marks the genesis of space and time, then you are, in a very real way, a fragment of that foundational explosion. Every person is a living testament to the matter and energy that burst forth from that initial moment, which forces a profound question about your role in the cosmos. Are you simply watching a grand universal play, or are you an active participant in a narrative that started at the dawn of time? The initial singularity remains an enduring puzzle that constantly tests the limits of human intellect. With each solution we uncover, a host of new questions emerges, making you wonder if you must accept that some mysteries are unsolvable. Yet perhaps the true elegance of science is found within this perpetual quest, fueled by the relentless curiosity that compels us to explore and inquire. Though the singularity might seem like a distant, abstract idea, its impact is felt throughout the entire framework of our cosmic understanding. Ultimately, the initial singularity marks more than just the birth of the universe. It signifies the dawn of our own pursuit of understanding. It encourages you to face the future with a sense of wonder, accepting how much remains unknown while recognizing that each new finding moves you nearer to solving the grand puzzle of spacetime. Every piece of the puzzle you solve brings you closer to comprehending your own significance within this immense cosmos. Among the most captivating concepts in contemporary cosmology is the expansion of the universe. To grasp what this actually means, picture the universe as a simple balloon. As you blow air into it, the balloon's surface stretches, causing any dots you've drawn on it to move away from one another. In much the same way, the very fabric of space is stretching, carrying galaxies and their clusters ever further apart. You might wonder about the rate of this expansion and its importance for our concept of time. The key is found in Hubble's law, a principle revealing that galaxies recede from us at speeds directly proportional to their distance. The more distant a galaxy, the faster it appears to flee. This creates a unique situation where there is no central point of expansion. Instead, every galaxy is moving away from every other galaxy, as if they are all simultaneously spreading out. Let's think about what this cosmic expansion implies for the nature of time itself. Certain scientific viewpoints propose that time's progression is fundamentally tied to the universe's growth. As space expands, time advances. However, your very perception of time as a relentless, forward-moving stream is intertwined with this expansion, though this feeling could be illusory. If you could pause the universe, stopping its expansion, you'd find that time itself might cease to exist, raising the profound question of whether it's merely a property of a growing cosmos. There is also a deep connection between the universe's expansion and the concept of entropy, which you can think of as a measure of a system's disorder. The general tendency is for entropy to rise as the cosmos expands, which gives us the arrow of time, the distinct forward direction you experience. Consider a glass shattering on the floor. This event represents a sharp increase in entropy. The impossibility of the shards spontaneously reassembling into a whole glass demonstrates this principle and is a physical manifestation of time's irreversible march. You can see the link between cosmic expansion and time through the phenomenon of redshift. As distant galaxies speed away from us, the light they radiate is stretched, shifting it towards the redder portion of the electromagnetic spectrum. This redshift effect serves as direct evidence for an expanding universe, but it also offers valuable insights into the universe's age and developmental history. Consequently, whenever you gaze up at the stars, you are quite literally peering back into the distant past. So, how does all of this reshape your understanding of time itself? The concept of an expanding universe, with time inseparably bound to its growth, compels you to fundamentally reconsider the nature of temporality. It raises the question of whether time is a tangible resource that can be quantified and manipulated, or if it is simply an emergent property of cosmic expansion. As you explore these concepts more deeply, you'll find the lines between science and philosophy blurring, each providing a unique lens through which to view the enduring mystery of time. In this context, it's intriguing to think about how the universe's expansion also prompts questions about the future. If the cosmos carries on expanding without end, what is the ultimate fate of time? Some scientists theorize that we might arrive at a state where the universe cools to such a degree that all stellar activity halts, signaling a form of thermal death. In that scenario, time could lose its relevance entirely, as no events would occur to signify its passage. The expansion of the universe is therefore more than just an observable event. It's a profound phenomenon that reshapes our very concept of time. This forces us to re-examine everything we believe about the past, the present, and the future. Could we devise different ways to measure time in a constantly stretching cosmos? Do other dimensions exist where time behaves according to different rules? These inquiries are still wide open for exploration and debate. As we continue to probe these cosmic enigmas, the universe's expansion serves as a powerful reminder of how much remains to be discovered. It compels us to look up at the stars and question our own place within this immense, ever-evolving reality. Time as we perceive it is merely one component of a far more intricate existence. Contemplating this connection between cosmic expansion and time can evoke a deep sense of awe, suggesting that time might not be a linear progression, but a web of interconnected moments unfolding across an expanding canvas. Einstein's theory of relativity, introduced in the early 20th century, fundamentally altered our comprehension of time and space. But what does this revolution in thought actually mean for how you perceive your daily life? Typically, when we discuss time, we visualize it as a uniform, straight line. Relativity, however, reveals that time is far more complex. It's better imagined as a vast terrain where each of us charts a unique course depending on our specific circumstances. Let's take a familiar example to illustrate this. Suppose you are on a train traveling at a very high velocity. If you glance at your watch, time appears to tick by normally. But what would a friend standing on the station platform observe? To them, your time on the train would seem to pass more slowly. This is the core of time dilation, a key phenomenon described by Einstein. As you approach the speed of light, time literally stretches out, causing it to flow slower for someone in motion, compared to a stationary observer. This phenomenon brings up an amazing question. Can time actually flow at different rates for different individuals? The answer from relativity is an unequivocal yes. The theory demonstrates that time is pliable, molded by both speed and gravity. The nearer you are to a massive celestial body, like a planet, the more slowly time will pass for you relative to someone positioned far from that gravitational influence. This concept, though it may seem strange, has been repeatedly validated through scientific experimentation. So why is this principle so significant? Relativity not only deepens our understanding of the universe's mechanics, but also dismantles our conventional notion of the word now. When we speak of events in the past or future, we tend to see them as fixed points on a single timeline. Yet, within the framework of relativity, what one person considers the present moment can be entirely different for another observer. It's as if every individual carries their own personal clock, each ticking at a distinct and personal pace. Now, if time itself is malleable, what implications does this have for our understanding of causality? Causality is, quite simply, the fundamental link between a cause and its effect. If event A triggers event B, could time behave in such a way that an observer might witness B happening before A? This is one of the most captivating puzzles raised by relativity, and it steers us toward concepts like wormholes and the possibility of time travel. Wormholes are theoretical constructs derived from Einstein's equations that could potentially link two remote points in the fabric of spacetime. Picture folding a piece of paper so that two distant points on its surface are brought right next to each other. While this idea has sparked considerable imagination, it also creates profound questions about the nature of time and our potential to interact with it. Some scientists speculate that if a wormhole could be stabilized, it might be possible to journey through it to another moment in time. But this is where paradoxes begin to emerge. If you were to travel back in time and alter a past event, how would that ripple through and affect the future? Dilemmas like this compel us to consider the deep philosophical consequences of time's relative nature. Relativity has also reshaped our perception of space. Instead of viewing space and time as two separate concepts, Einstein demonstrated their intricate connection within a single four-dimensional continuum known as spacetime. This means that any alteration in one directly influences the other, much like stretching a rubber sheet changes not just its shape, but its entire structure. As we delve further into relativity, it encourages us to contemplate travel into the future. If it were possible to journey at extraordinary speeds, we could theoretically jump forward in time. This concept, a staple of science fiction, also forces us to question the very essence of time itself. If time is relative, does a definite, fixed future that we can travel to even exist? Einstein's theory also opens up the possibility that time might have no true beginning or end, challenging ideas like the Big Bang as an absolute starting point. Ultimately, relativity invites you to see time not as an unyielding force marching relentlessly forward, but as a dynamic companion that adapts and transforms with you. It is a reminder that your experience of time is profoundly personal and unique. Instead of being a straight, unbending line, time may be more akin to an ever-shifting landscape, rich with nuance and filled with possibilities. The search for answers to these profound questions is what continues to fuel our exploration and understanding of the universe and our own position within it. Each one of us constructs a unique timeline, woven from our personal experiences and perceptions, a concept that mirrors the diversity of the cosmos itself. Albert Einstein's theory of relativity illuminates how, even though we inhabit a shared space, our individual encounters with time are incredibly varied. Ultimately, investigating whether time originated with the Big Bang transforms into a thrilling expedition into the unknown, a journey that we are only just beginning to undertake. For many of us, the very notion of time existing before the universe's birth is as bewildering as it is captivating. What could time before the Big Bang genuinely signify? It's possible that time, as we comprehend it, simply did not exist prior to this foundational explosion. To grasp this challenging idea, we must first delve into some of the theories that strive to solve this profound mystery. One of the most compelling questions that scientists grapple with is whether time truly commenced with the Big Bang. A prominent argument suggests that this event marked not only the beginning of the universe, but also the dawn of time itself. According to this perspective, there was no before the Big Bang, because the framework of time had not yet come into being, forcing us to conceive of a reality devoid of both space and time. However, the concept of non-existent time presents a significant intellectual challenge. What does it actually mean for time not to exist, especially when it is such a fundamental component of our daily lives, something we constantly measure, feel, and organize our existence around? Some scientists propose a pre-Big Bang state, where the known laws of physics would completely collapse, leaving us to wonder if something could have preceded the creation of time and space. Alternative models suggest that before the Big Bang, time might have been an entirely different kind of phenomenon. In this view, you could picture time not as a forward-flowing river, but as a placid ocean where all events exist simultaneously rather than in sequence. This line of thought compels us to reconsider our fundamental assumptions about cause and effect, as well as the very divisions between past, present, and future. Conversely, some theorists champion the idea that time in its familiar form is merely a byproduct of the universe's continuous expansion. From this standpoint, the Big Bang was the cataclysmic event that initiated our experience of linear time. If this holds true, it suggests that time itself might be an elaborate illusion, a perception generated by the cosmic evolution unfolding around us, which raises profound questions about our understanding of reality. Another fascinating theory revolves around the possibility of a cyclical timeline. Certain researchers propose that the universe undergoes infinite cycles of expansion and contraction, which would imply that our Big Bang was not the first. In such a scenario, time would not be a linear progression, but an eternal loop, a concept that presents challenges when trying to reconcile it with our current cosmological observations. This inquiry into time before the Big Bang inevitably leads us into the realm of philosophy. Various philosophical traditions have debated whether time is a human construct designed to make sense of the world, or if it exists as an independent entity. If time can indeed begin and end, it opens up the possibility of a temporal dimension outside our own universe, one that we are incapable of perceiving. It is truly astonishing to consider that while the Big Bang represents a definitive moment in cosmic history, we are still far from having all the answers. As science advances, so does our comprehension of time and the universe. Every new hypothesis about the nature of time before the Big Bang reflects our deep-seated curiosity and our drive to comprehend the unknown, bringing us progressively closer to the secrets of existence. Some scientists are now turning to quantum mechanics to explore the question of time from a new angle. This perspective suggests that time may be far more flexible than we imagine, creating the possibility that it is not a universal constant. Perhaps on the most fundamental stratum of reality, time operates under entirely different rules than what we experience, which would dramatically reshape our understanding of the past and future. The absence of time before the Big Bang also forces us to confront essential questions about the nature of the universe itself. If there was no time, how did matter come into existence? What possible mechanisms could have triggered the creation of an entire cosmos out of nothingness? These inquiries push us to the very edge of physics and philosophy, into a territory where scientific theory meets informed speculation. As we journey deeper into the history of the cosmos, we begin to see that the Big Bang was more than just a physical event. It was a turning point in our conceptualization of time. Each new theory and discovery challenges our established beliefs about temporality. As we continue to investigate these mysteries, a vast landscape of possibilities opens up regarding what time truly means, not just for the universe, but for our own lives. The search for answers about the origin of time is a perpetual quest. Every solution seems to yield new questions, and each theory invites us to look beyond the boundaries of our current knowledge. In this light, the puzzle of time before the Big Bang is not merely a scientific enigma. It serves as a powerful source of inspiration, compelling us all to continue exploring the vast unknown. Ultimately, time remains one of the universe's most profound wonders. Why does it appear to travel in only one direction, from the past toward the future? This and other intriguing questions have long perplexed philosophers and scientists alike. The answer may reside in a concept known as the arrow of time. And in seeking to understand it, perhaps we are also on a journey to better understand ourselves. This idea is not just crucial for grasping the nature of time, it also encourages you to contemplate how you perceive your own existence within the universe. The arrow of time is a powerful metaphor for the unidirectional flow we experience, often broken down into three distinct concepts: the thermodynamic arrow, the psychological arrow, and the cosmological arrow. The thermodynamic arrow is rooted in the second law of thermodynamics, which dictates that entropy, the measure of disorder within a system, will always tend to increase. This essentially means that as time moves forward, systems naturally progress toward a more disorganized and chaotic state. You can see this principle in action by observing how much more effort it takes to organize a room than to let it descend into messiness. The psychological arrow, in contrast, is tied directly to your perception. You can access memories of the past, but you cannot remember the future, which creates the sensation of time flowing in a straight line from past experiences to future ones. This subjective sense of time can feel elastic. Have you ever noticed how time seems to fly by when you are engaged and drag on endlessly when you are bored? The cosmological arrow is linked to the expansion of the universe on the grandest scale. Since its inception at the Big Bang, the cosmos has been continuously expanding, causing galaxies to move away from each other. This cosmic evolution itself suggests a direction for time, one that is tied to the development of the universe as a whole. What's truly captivating is the inseparable connection between the arrow of time and entropy. As disorder increases, it drives observable changes in the physical systems all around us. For instance, think of a glass of hot water left to sit. Initially, its thermal energy is concentrated and ordered, but over time, that energy dissipates and the system becomes more disordered as the water cools. This same principle applies to everything from planets to stars, as all systems gravitate toward a state of equilibrium. This relentless increase in entropy, however, brings up some profound questions. Does it imply that time itself has a definite beginning and a predetermined end? Some scientists theorize that the universe's expansion could be part of a grand cycle of creation and destruction. In such a scenario, perhaps time is not a linear path but a great wheel, turning without end. When you explore the arrow of time, you inevitably encounter the paradoxes presented by quantum mechanics. In the quantum realm, particles can behave in ways that defy our everyday intuition about time's flow. At the subatomic level, for example, particles can exist in multiple states at once. Does this suggest that our linear understanding of time is incomplete, and that multiple arrows of time might coexist in the quantum world? Further complicating matters is Einstein's theory of relativity, which shows that time is not a universal constant. The rate at which time flows can vary depending on your speed and the gravitational forces you experience. This implies that, under certain conditions, you could live through time in a manner completely different from what you are accustomed to. Just imagine residing in a place where time itself unfolds more slowly. The link between time and space is equally fascinating. The universe's expansion affects not only the distribution of galaxies, but the very structure of time itself. As the cosmos expands, time also appears to be in a constant state of transformation. It may be that our comprehension of time is fundamentally tied to the history and ongoing evolution of the universe. When you bring this concept back to your own life, you can see how the arrow of time profoundly shapes your daily reality. How you live, the choices you make, and the memories you hold are all framed by your perception of time moving forward. Every second gains significance, and each moment becomes a critical component of your personal experience, influencing how you value your life and your relationships. The arrow of time, with its many layers and complexities, invites you to question everything you thought you knew about the universe. It is a powerful reminder that time is not simply a resource to be measured, but a foundational force that shapes our very existence. As we advance into an unknown future, the exploration of time and its properties remains a captivating journey that unites us all. In our day-to-day lives, we experience time as something linear and continuous. Yet in the quantum world, the rules seem to change entirely. There, reality is so bizarre that it challenges even our most basic understanding of time. Is time an illusion, or is it simply an aspect of the universe that we have yet to fully comprehend? While classical physics describes time as a constantly flowing river, this notion dissolves at the smallest scales. One of the most compelling questions is why time behaves so differently in the quantum realm. In this microscopic universe, particles do not possess a definite position or velocity until we attempt to measure them, a phenomenon known as superposition. They don't seem to follow a predictable trajectory, acting instead as if they are more focused on the present than a defined future. Imagine being in a garden of flowers where, until you look at a specific one, every flower could be any color. Only the act of observation makes one red and another blue. That is the strange reality where our conventional understanding of time breaks down. In quantum mechanics, the very act of measurement has a direct impact on what you observe. But what if I were to suggest that time, at the quantum level, might actually be reversible? In our everyday world, it's completely clear that time flows in a single direction, from the past into the future. However, within the quantum realm, some theories speculate that fundamental processes could potentially run in reverse. Can you envision a reality where actions could be undone, as if your entire life were a video that you could simply rewind? This presents a fascinating dilemma concerning the true nature of time and causality. Quantum entanglement, another profoundly intriguing phenomenon, also compels us to reconsider our ideas about time. When two particles become entangled, the state of one appears to instantaneously shape the state of the other, regardless of the physical distance separating them. This peculiar connection raises the question of whether time and space are as fundamentally inseparable as we have always believed. Perhaps time, as you perceive it, is more closely tied to our perception than it is to an objective physical reality. Some theories even propose that time might be an emergent property, something that arises from the immense complexity of interactions between particles. In the same way that temperature is an emergent measurement of energy within a system, time could be a construct built from our impressions and observations, rather than a fundamental component of the universe. What if the linear flow of time is merely an illusion, meticulously crafted by our minds to help us make sense of the world around us? Then there is the captivating question of how gravity influences time within the framework of quantum mechanics. Einstein's theory of relativity demonstrated that time is susceptible to the effects of gravity, which can stretch or compress it based on proximity to a massive object. But what happens when you combine this principle with the bizarre rules of the quantum world? Many scientists believe that a comprehensive theory of quantum gravity may hold the answers. but we are still in the early stages of understanding how all these pieces fit together to form the grand puzzle of the universe. It is crucial to remember that quantum mechanics isn't just a collection of strange, abstract rules. It has been validated by innumerable experiments, which have enabled us to create technologies like lasers and semiconductors. And yet, despite its practical successes, the paradoxical nature of quantum theory continues to challenge our fundamental understanding of time. This raises profound philosophical questions. If time is an emergent construct, what does that mean for your life and your decisions? Are you locked into a predetermined temporal flow, or do you possess the ability to influence your reality in ways you don't yet comprehend? Certain interpretations of quantum mechanics, such as the many worlds theory, suggest that every choice you make could trigger a branching of time, thereby creating parallel universes. This introduces a truly mind-bending possibility. Does every single moment of your life actually spawn an infinite number of alternative realities? If time is indeed this pliable, it forces us to reconsider the very nature of our experiences and memories. In this context, time transforms from a simple measure of event duration into a concept deeply intertwined with consciousness and perception. Perhaps your experience of time is as subjective as your perception of light or sound, a sensory experience that naturally varies from one observer to another. Quantum mechanics, with its bewildering dance of particles and probabilities, offers you a glimpse into a universe that defies our most basic assumptions. As we continue to delve into this fascinating field, our notions of time and reality are likely to evolve in ways we can't yet even begin to imagine. Modern cosmology doesn't just inform us about the universe. It also tells us something profound about an experience you have every day, the passage of time. But how are cosmology and time connected? Is time simply a passive backdrop for the universe's events, or does it play a more significant role? To find the answers, it is essential to explore how scientists started to understand time in the context of our expanding universe. The discovery of the Big Bang forced scientists to rethink many of their established ideas about time itself, leading to the theory that before this cosmic explosion, time as you know it may not have even existed. The expansion of the universe is one of the most compelling concepts that cosmology has presented, and it has fundamentally changed our perception of time. Instead of viewing it as a fixed and rigid framework, time becomes a dimension that can be directly influenced by the universe. To help you grasp this, imagine a balloon being inflated. As it expands, all the points on its surface move farther apart from one another. This analogy helps us visualize how time itself might be stretching right along with the expansion of the cosmos, demonstrating its flexibility depending on the context in which it exists. As we explore the connection between cosmology and time, we find that Einstein's theory of relativity plays an absolutely crucial role. Before his groundbreaking work, time was widely regarded as absolute and uniform for everyone, everywhere. His theories, however, replaced this static picture with a dynamic one, where time is relative and interwoven with the fabric of space, forever linking our understanding of the passage of moments to the grand evolution of the universe itself. What truly is time? Is it simply a way to measure change, or does it possess a more profound essence? For centuries, humanity has grappled with this concept from numerous angles, with each perspective adding a new layer to its elusive nature. From ancient Greek thinkers to contemporary scientists, time has been a subject of intense reflection, where every answer only seems to generate more questions. Philosophy has offered some fascinating viewpoints on time. Some, like Immanuel Kant, proposed that time is a framework our minds use to structure experience, essentially making it a mental construct. In contrast, others like Aristotle saw it as an observable phenomenon, measured by physical changes in the world. This fundamental conflict, whether time is a subjective illusion or an objective reality, has remained a central debate throughout history. In the realm of science, time was long considered a fundamental constant of the universe, flowing uniformly and absolutely according to classical physics. However, Einstein's theory of relativity completely shattered this view, introducing the concept of relative time. It dictates that the pace of time depends on your velocity and the gravitational forces acting upon you. Can you grasp the idea that your watch could display a different time based on your position in the cosmos? Black holes present another fascinating challenge to our understanding of time. Picture yourself traveling toward one. As you draw nearer, time itself begins to behave erratically. For a friend observing from a safe distance, you would appear to slow down dramatically as you approach the event horizon. This raises a profound question. Does time merely flow forward, or does it also bend and warp under the immense influence of gravity? On the grand scale of our expanding universe, the concept of the arrow of time becomes critically important. This principle, which describes the one-way direction of time's movement, seems to be directly linked to the increase of entropy, or disorder, in the cosmos. In essence, as the universe expands and cools, it naturally progresses toward a more chaotic state. This connection offers a powerful clue as to why we perceive time as moving relentlessly from the past into the future. As we explore cosmology more deeply, the need to measure time on cosmic scales becomes apparent. How do we even begin to calculate the age of the universe? Astronomers employ a range of techniques, from observing the life cycles of stars and galaxies to analyzing the cosmic microwave background, also known as relic radiation. These methods enable scientists to piece together a universal timeline that stretches back billions of years. Quantum mechanics also introduces its own perplexing twist to our perception of time. At the subatomic level, particles exist and interact in ways that seem to defy conventional logic, leading some theories to suggest that time as we know it may not even exist in the quantum world. This idea, while baffling, highlights just how complex the nature of time is and how it can change depending on the context in which it is observed. Ultimately, modern cosmology compels us to consider the philosophical weight of time's role in our universe. Is it a tangible force that shapes existence, or is it merely an illusion born from our own perception? These inquiries challenge not only our scientific models, but also our deepest beliefs about reality itself. The exploration of time is an ever-advancing frontier, where each new discovery brings us closer to solving one of the universe's greatest mysteries. The very idea of time has captivated human thought since the dawn of consciousness. But what happens when modern science begins to dismantle your fundamental perceptions of it? Across history, a variety of experiments have put our comprehension of time to the test, with some yielding results so startling they might compel you to reconsider everything you thought you knew. This leads to the central question. Is time merely a convincing illusion, or is it a tangible phenomenon that we have yet to fully grasp? One of the most iconic challenges to our conventional view of time is the twin paradox, a direct consequence of Einstein's theory of relativity. Picture two identical twins. One remains on Earth while the other undertakes a voyage through space at velocities approaching the speed of light. Upon their reunion, the traveling twin has aged less than the one who stayed behind. This effect, called time dilation, is not just a theoretical curiosity. It has been concretely verified using hyper-accurate atomic clocks on airplanes and satellites, proving that time is not absolute but relative to your motion. A similarly fascinating demonstration occurs within the core of particle accelerators. When scientists propel subatomic particles to nearly the speed of light, the lifespans of these particles dramatically extend. A particle that would normally decay in a fraction of a second is observed to exist for much longer, which challenges our intuitive sense of time as a constant, unchangeable force. These experiments raise the provocative possibility that by manipulating speed, you could effectively manipulate the flow of time itself, opening doors to unimaginable future technologies. Even more perplexing inquiries arise from experiments involving quantum clocks and the famous double-slit experiment. In the quantum realm, particles can exist in multiple states at once, prompting us to wonder if time itself could behave in a similar, non-linear fashion. Certain interpretations of quantum mechanics propose that time is not a fundamental constant, but an emergent property of the universe. Furthermore, the double-slit experiment shows that the act of observation changes physical reality, which begs the question, if your perception can influence reality, could you, in a sense, be a co-creator of your own timeline? Theoretical physics pushes these boundaries even further with concepts like wormholes. These hypothetical tunnels through the fabric of spacetime, permitted by the equations of general relativity, could potentially connect different moments in time. Although none have ever been discovered, their theoretical existence presents profound questions. If you could construct a wormhole, would it be possible to visit the past? And if you did, would such an act fundamentally alter the nature of time as we understand it? The paradoxes associated with time travel are a subject of intense debate. Imagine journeying into the past and encountering a younger version of yourself. If you were to give your past self information that altered their decisions, would you have irrevocably changed the future? While a common theme in science fiction, these complex causal loops are now being seriously contemplated by science, suggesting that the linear progression of time you experience may be far from the whole story. Finally, your understanding of time's direction is deeply connected to the concept of entropy. The second law of thermodynamics dictates that in any closed system, disorder or entropy will always increase. This relentless march toward chaos provides what is known as the arrow of time, explaining why you can remember the past but not the future. This leads to a tantalizing thought. If it were possible to reverse entropy, could you effectively reverse the flow of time itself? The implications of how you perceive time are truly profound, extending beyond science into art, literature, and your personal life. If time is indeed a construct of the mind, how does that knowledge reshape your relationships and experiences? From classic literature to modern film, the theme of time reflects our deepest hopes and fears, and these portrayals have undoubtedly shaped our collective culture. Contemplating these ideas is essential for a deeper understanding of both yourself and the universe. As you reflect on the nature of time, it becomes clear that despite our scientific advancements, there is still an immense territory left to explore. The intricate relationship between time, space, and matter remains a rich field for both scientific and philosophical investigation. As we persist in our quest for answers, it is vital to stay open to new ideas, because time, in all its complexity and mystery, will always invite you to question not just the cosmos, but your own place within it. These inquiries have spurred incredible research in both physics and cosmology, leading to a variety of astounding experiments that challenge our fundamental assumptions about time. From the twin paradox and time dilation to the theoretical possibilities of wormholes and temporal paradoxes, each concept compels you to reevaluate what you think you know. As scientific understanding advances, every new discovery brings us closer to solving this cosmic enigma, leaving an essential question unresolved. Is time a tangible dimension we can measure and control, or is it merely an illusion constructed by our own perception? Only the future holds the answer.
Since the beginning of recorded history, humanity has been captivated by the subject of time. You can see that from the most ancient myths to the most advanced scientific theories. Every culture has tried to comprehend what time is and how it intertwines with our existence. Have you ever considered how different civilizations have viewed this concept? The way you perceive time not only structures your daily life, but also profoundly shapes your understanding of the universe itself. Consider Greek mythology, where the figure of Kronos not only symbolizes time, but is also linked with consumption and relentless change. It's a striking detail that in some versions of the myth, Kronos devoured his own children to secure his power. A potent metaphor illustrating how time can be both a creator and a destroyer. This image of each passing moment as a lost opportunity that pushes you toward the future is a concept that is echoed throughout human history. The ancient Egyptians, by contrast, held a very different view of time as a cyclical phenomenon, defined by renewal and rebirth. Their belief in the recurring pattern of life, death, and resurrection was a cornerstone of their culture. By observing the Nile's annual floods, they understood that time doesn't just advance in a straight line, it also circles back on itself. This prompts you to ask, is time more like a river flowing in a single direction, or is it an eternally repeating loop? In Eastern philosophies like Buddhism, time is often regarded as an illusion, a phenomenon without any genuine, independent existence. This notion might seem difficult to grasp. How could something as fundamental as time be unreal? In this framework, time is seen as a mental construct, implying that your sense of its passage is just a subjective interpretation of your experiences, rather than an objective reality. In Mesoamerican cultures, time was treated as a sacred force. They developed an incredibly precise calendar and held that every cycle of time was intricately linked to cosmic and spiritual events. This perspective invites you to consider the deep connections between time, the cosmos, and spirituality. Meanwhile, many Native American cultures perceive time not as a linear progression, but as something deeply integrated with the natural world. Suggesting a harmonious relationship with the planet's cycles could transform your own connection to life. Hindu mythology portrays time as a vast cycle of creation and destruction, known as the Yuga cycle. Each yuga possesses a distinct character and duration, and together they create a cosmic timeline spanning thousands of years. This idea of cyclical time makes you question the pressures of modern life, which is so often governed by a linear, forward-moving clock, and wonder if you should reassess your priorities and how you experience time day to day. As we've entered the modern age, our scientific grasp of time has evolved dramatically, with contemporary physics challenging many long-held beliefs. For example, are you aware that according to Einstein's theory of relativity, time is not an absolute constant? Instead, its passage depends on an observer's speed relative to an object. This revolutionary idea forces you to question whether time is a steady, unchanging force or a flexible concept that adapts to your unique experience. The diverse cultural interpretations of time have also shaped how scientists investigate this phenomenon. While the notion of linear time is deeply embedded in our daily lives, scientific evidence suggests it can be far more intricate. This complexity has profound implications for your quest to understand the universe and your own place within it. Even popular culture, through films, books, and television, has explored concepts like time travel, prompting you to wonder if it's possible to alter the past or see the future, reflecting a deep human desire to master time itself. Ultimately, the relationship between a culture and its concept of time serves as a reflection of its core beliefs and values. Each unique interpretation offers a different lens through which to understand your place in the cosmos. By exploring these varied narratives, you might discover a more profound connection with yourself and the universe. The next time you glance at a clock or contemplate the future, remember that time is more than a simple sequence of minutes and hours. It is a rich and nuanced construct shaped by history, culture, and science. Reflecting on time encourages you to look deeper into your own existence and ask what it truly means to live in a universe of constant change. So, when you contemplate the nature of time, it's helpful to remember the vast ocean of interpretations that surround us. Each culture has offered its own unique viewpoint, enriching our collective understanding and helping us navigate the intricate tapestry of reality. Have you ever gazed at the night sky and asked yourself how astronomers manage to piece together the history of the universe? A large part of the answer is found in the Big Bang, the cosmic event that most scientists agree marks the origin of everything we can observe. The connection between the Big Bang and modern astronomy is both fundamental and filled with enduring mysteries, which we can begin to explore by first understanding what the Big Bang truly represents. Picture how a collapsed balloon stretches outward in every direction as it's filled with air. This provides a simple analogy for the Big Bang, the initial event that brought all of space and matter into being. But what is the connection between this origin point and the study of the stars and galaxies around us? Astronomers rely on the model of an expanding universe to retrace the cosmic history of galaxies. Every single galaxy you can observe has its own distinct past, and each of those stories originates with the Big Bang. When you gaze upon a distant galaxy, you are doing more than just observing its light. You are peering deep into the past. The illumination from a faraway star that finally reaches your eyes may have embarked on its journey millions or even billions of years ago. In this sense, astronomers function as cosmic detectives, piecing together clues from the universe's earliest moments. But what evidence confirms that the universe is indeed expanding? A pivotal moment in our understanding came from the research of Edwin Hubble during the 1920s. Hubble made the groundbreaking discovery that galaxies are moving away from us, and their speed of recession increases with their distance. You can visualize this by imagining you're at a party and toss confetti into the air. You'd notice the pieces farther from you appear to move away faster than those nearby. This observation is encapsulated in what we now call Hubble's law, a fundamental principle for comprehending how the Big Bang has shaped our cosmos. With every new finding, astronomers have managed to assemble a more detailed portrait of the universe's life story. By studying radio waves, visible light, and other forms of radiation, they have uncovered patterns that illustrate how galaxies formed and developed out of this foundational cataclysm. But what does all this signify for us, as observers here on Earth? It grants us a profound perspective on our own position within the grand cosmic scheme. Every star you see twinkling in the night sky is, in a way, a direct descendant of the Big Bang. Stars are born from vast clouds of gas and dust that have been interacting in a continuous process that started billions of years ago. The light from these celestial bodies opens a portal to the past, giving us a glimpse of how the universe has transformed since its inception. Is it not remarkable to consider that by simply looking up, you are connecting with the dawn of existence? However, the field of astronomy isn't solely focused on cosmic expansion and galactic formation. It also explores the fundamental nature of time itself.
Through the study of the cosmic microwave background, also referred to as relic radiation, the residual thermal energy that fills all of space, scientists have gained insights into how matter was arranged in the early cosmos. This radiation serves as a kind of snapshot of the universe in its infancy, helping us piece together how it cooled and evolved over eons. The implications of the Big Bang reach far beyond a historical account, prompting us to ask critical questions about our own place in the universe and its ultimate destiny. If the cosmos continues to expand indefinitely, what does the future hold? Some hypotheses propose an eventual Big Crunch, where all matter collapses back in on itself, while other theories predict a universe that expands forever. This uncertainty encourages us to contemplate the intricate relationship between time and space. As our technology progresses, the tools of astronomy grow ever more powerful. Advanced telescopes and new observational methods permit scientists to probe regions of the universe that were once beyond our reach. These developments not only deepen our knowledge of the Big Bang, but also introduce new questions about what might exist beyond the limits of our observable cosmos. Could there be other universes? And if so, how might they be related to our own? Ultimately, the Big Bang represents not just a singular event in the past, but the starting point for our ongoing exploration of everything. Every star, planet, and galaxy you observe is a chapter in a much larger narrative. Driven by the questions raised by the Big Bang, astronomy beckons us to remain curious, to pose new inquiries, and to search for answers in the boundless expanse of space. So the next time you cast your eyes to the heavens, remember that you're not just seeing stars, you're witnessing the history of the universe unfold. Is it conceivable that the universe never had a beginning at all, but has existed eternally in some form? This question has captivated scientists and philosophers for many years. Alternative frameworks to the Big Bang, such as the steady-state model and the cyclic model, present compellingly different views on the nature of the cosmos and its connection to time. The steady-state model posits that while the universe is perpetually expanding, new matter is continuously created to fill the gaps left by receding galaxies, thus keeping its overall density constant. How, though, can this concept be squared with our observations of the cosmic microwave background radiation? This faint afterglow, which strongly resembles an echo of the Big Bang, seems to be clear evidence of a singular starting point. Proponents of the steady-state idea, however, contend that this radiation could simply be a component of an unending, infinite cycle. But what if the universe is locked in an eternal rhythm of expansion and contraction? This is the central idea of the cyclic model. According to this theory, the cosmos undergoes vast eras of expansion, like the one we are in now, which are eventually followed by periods of contraction, culminating in a big crunch. This entire sequence would then repeat itself endlessly, suggesting our universe is merely one episode in an infinite series. What are your thoughts on this possibility? Could it imply that time is not a linear progression but a recurring loop? These alternative models don't just question the Big Bang. They compel us to reconsider the very essence of time itself. This is a realm where philosophy and science converge, giving rise to immense implications. The concept of a cyclical timeline has the power to completely reshape your understanding of your own life and your position within the cosmos. Yet, these alternative models are not without their skeptics, as many scientists point out a significant lack of compelling observational data. Most current evidence, including the accelerating expansion of the universe and cosmic radiation, appears to offer stronger support for the Big Bang theory. But you have to wonder what might happen if new evidence supporting these alternative frameworks were to surface. Science is in a perpetual state of evolution. What seems improbable today
could very well become the cornerstone of our cosmic understanding tomorrow. Moreover, our fascination with these theories introduces another compelling topic: the intricate connection between time and space. Within a cyclical universe, the nature of time itself might be far more malleable than we currently imagine.
It's possible that time isn't a linear progression at all, but is instead entwined with space in ways that are still beyond our comprehension. Picture a vast tapestry where every single thread signifies a complete cycle of the universe, all interwoven to form an elaborate and complex design. Could it be that your perception of time is merely a restricted glimpse of a much grander reality? Inquiries like this compel us to venture beyond the limits of our present knowledge. Alternative Big Bang theories unlock entirely new avenues for contemplating the universe. This isn't just a matter of deciphering past events. It's also about recognizing how our perception of time and space shapes our grasp of the future. Ultimately, what does all of this suggest about the fundamental nature of existence? In this quest for answers, it is truly captivating to see how these abstract ideas resonate with our day-to-day lives. Embracing the idea of cyclical time could fundamentally alter the way you choose to live. If time operates in a recurring loop, then every single moment transforms into a fresh chance for learning and personal development, rather than just a point on a finite line moving toward its conclusion. Such a concept can be simultaneously liberating and deeply profound, as these alternative models invite you to challenge your most basic assumptions about the cosmos and your role within it. In an era where science and philosophy are often perceived as conflicting disciplines, these concepts demonstrate their potential for a harmonious interplay, fostering a dialogue that profoundly deepens our collective understanding. As you delve into these theories, it's important to recognize that each question you pose is a step toward a more complete grasp of reality. The exploration of the cosmos and time ultimately becomes a lesson in our own existence, reminding us that even if we feel insignificant in the vastness of the universe, we each contribute to this unending narrative. The search for the origins of the universe and the nature of time is, at its heart, a search for meaning. The fascinating question of how time is measured across the immense scale of the universe has long captivated the minds of both scientists and philosophers. To grasp how we track time in a cosmic framework, you must first grapple with the concept of time itself. While we typically imagine it as a constantly and relentlessly flowing river, its behavior becomes far more intricate when viewed on a universal scale. On our planet, we rely on clocks, calendars, and natural rhythms like the rising and setting of the sun to mark the passing of moments. Once you turn your gaze to the stars, however, the situation grows significantly more complex. How can you possibly create timekeeping devices that function across such a boundless expanse? This is where the properties of light become absolutely essential, as its constant speed serves as our universal yardstick for measuring not only distance, but also time across the cosmos. When you observe a star in the distant sky, you are not just seeing its light. You are literally looking back into the past. The photons reaching your eyes from a star that is thousands of light years away are revealing what that star looked like thousands of years ago. This means the universe is brimming with echoes of its own history, and every glance at the night sky connects you with a moment in time that is long since passed. But what occurs when cosmic phenomena are so extreme that they defy our conventional understanding of time? Black holes provide a perfect example of this, as time behaves in very peculiar ways in their vicinity. As you draw closer to a black hole, the gravitational pull becomes so intense that time itself appears to decelerate. If you were near one, time would pass more slowly for you, and to a remote observer,
you would seem to be almost frozen in place, prompting the question, is time truly an unwavering constant, or is it relative to your position in the universe? In any discussion about time, the expansion of the universe is a factor that cannot be overlooked. The cosmos has been in a state of continuous expansion since the moment of the Big Bang, and this has a direct impact on how we measure time. The fact that galaxies are perpetually moving away from one another adds another layer to our calculations. When you observe a faraway galaxy, you are witnessing not only its light from a distant past, but also its journey through space, which helps illustrate just how deeply time and space are intertwined.
As our exploration extends beyond nearby stars and galaxies, we encounter the principle of relativity. Einstein's theory demonstrates that time is not a uniform entity. It can be stretched or compressed based on your velocity and the gravitational forces you are subjected to. This revolutionary idea has been validated through numerous experiments, with a classic illustration being atomic clocks. Timepieces moving at high speeds, like those on satellites, record time differently than their counterparts on Earth, proving that time's passage can change depending on where and how you measure it. Establishing a consistent measure of time presents immense challenges on a cosmic scale. In the profound depths of space, devoid of familiar reference points like the sun or moon, how can you determine how much time has gone by? To solve this, scientists have devised innovative techniques, using everything from the regular oscillations of atoms to the cosmic microwave background, also known as relic radiation left over from the early universe. While each method brings us closer to a cosmic understanding of time, they also leave a host of questions, such as the possibility of time travel, unanswered. While this concept might seem like pure fantasy in science fiction, it poses profound questions within the field of theoretical physics. The hypothetical ability to journey through time forces us to rethink our entire understanding of its relationship to the universe. If time is indeed a dimension, much like the three dimensions of space, could we ever develop a method to navigate it? It's essential to recognize that science is in a constant state of evolution as we explore these ideas. Modern cosmology is currently grappling with challenges that push beyond our conventional notions of time. Every new discovery raises a fresh set of questions, and each of these questions provides an opportunity for deeper exploration. The search for a complete understanding of time's nature is a potentially infinite journey. As scientists continue to investigate the cosmos and pioneer new technologies, the very instruments we use to measure time are also advancing, giving us new perspectives. This evolution reveals that time is not merely a physical quantity, but also a profoundly human experience. The ways in which you measure it can reveal a great deal about yourself and your position in the universe. The subject of time within our cosmos is an expansive and enthralling field, filled with mysteries that are still waiting to be solved. How you perceive and quantify it links you to the past and provides hints about what lies ahead. As our comprehension deepens, it's worth remembering that each passing second offers a glimpse into the cosmos, a reminder that time is fundamentally one of the most potent forces you will ever encounter. But could it be that time, as you perceive it, is nothing more than an elaborate illusion? Across history, the notion of time travel has fascinated scientists and filmmakers alike, often blurring the line between established science and speculative fiction. So, what do the established laws of physics have to say about this captivating possibility? The idea of visiting the past or jumping into the future has captured the minds of countless people, but is this a genuine scientific option or simply wishful thinking? Einstein's theory of relativity, which fundamentally altered our perception of space and time, serves as the ideal foundation for this inquiry.
According to Einstein's framework, time is not a universal ticking clock, but rather a dynamic fabric that can expand and contract. Its passage is relative, changing based on the speed you are traveling and the intensity of the gravitational forces you are subjected to. This means that if you were to travel at velocities approaching the speed of light, time would slow down for you in comparison to those who remain still. To grasp this, picture a scenario with two twins. One remains on Earth while the other embarks on a high-speed journey through space. When the spacefaring twin returns, they may discover that their sibling on Earth has aged significantly more. This effect, known as time dilation, demonstrates that time is far more pliable than our everyday experience suggests, which naturally leads to a difficult question. If time is this flexible, can you manipulate it to travel backward into the past? Many are drawn to the idea of returning to correct historical mistakes, but physics issues a stern warning that such actions could trigger paradoxes. The most famous of these is the grandfather paradox. If you were to travel back and stop your grandparents from ever meeting, you would never have been born to make the trip, creating an impossible contradiction. Adding to the complexity, quantum mechanics introduces another layer of strangeness to this puzzle. In the subatomic realm, particles are capable of existing in multiple states at once and can appear to traverse different paths through time. This has prompted some scientists to theorize that time travel might not just be possible, but perhaps is already occurring in some unseen way, though harnessing these quantum effects remains purely speculative. Some theories propose that such a feat would require something called a wormhole, which is a hypothetical tunnel through the fabric of spacetime connecting two distinct points in time. However, the actual existence of these cosmic shortcuts has yet to be proven. While the concept of a wormhole offers a tantalizing gateway to different eras, it is accompanied by numerous scientific hurdles that seem insurmountable for now. For instance, keeping a wormhole stable would necessitate a type of exotic matter with properties we have not yet discovered. So, while the notion is compelling, the truth is that we are nowhere near having the technology or the theoretical understanding to make such journeys a reality. Science fiction has certainly given us countless imaginative takes on time travel, with films like Back to the Future and Interstellar popularizing the concept. These stories have made the idea feel exciting and accessible, but they often simplify the incredibly intricate scientific principles that would need to be overcome. It's fascinating to observe how popular culture has embraced time travel, even as the real-world science remains deeply complex. The philosophical proposition that time itself is an illusion is also a powerful and recurring theme in human thought. Some philosophers contend that the past and future are merely mental constructs and that only the present moment is truly real. If that perspective is accurate, what meaning would time travel even hold? Would it be possible to alter a past or future that exists only as a perception in your mind? As science progresses, our comprehension of time will undoubtedly continue to change. Perhaps, at some point in the future, we will develop new theories that offer a much clearer view on the feasibility of time travel. Until then, the very act of exploring the concept compels you to question not only the nature of time, but also your own existence and the part you play in the grand fabric of the universe. The notion that time might not be a single arrow flying forward, but a vast ocean of possibilities, invites you to reflect on your own life and choices. Ultimately, while traveling through time may remain in the realm of fantasy, the act of questioning it drives us to explore the profound mysteries of our universe more deeply. Science and philosophy have a great deal more to investigate on this topic, and every new insight may bring us one step closer to understanding the true essence of time and its intricate connection to your journey through life. From the dawn of consciousness, the concept of time has captivated the human mind. But what is it, fundamentally? Is time simply a convention we use to measure change, or does it represent a deeper, more essential component of the universe's very structure? Across history, both philosophers and scientists have dedicated themselves to decoding its secrets, attempting to grasp its true nature. Some have pictured time as a great river, flowing onward without pause and sweeping the moments of our lives along in its current. For others, it is more like a vast stage where the entire spectacle of existence is performed. Contemplating these metaphors forces you to consider their profound implications for how we understand the cosmos and our own unique position within it. One of the most compelling debates is whether time proceeds in a straight line or moves in a circle. A linear model suggests that every moment is singular and can never be reclaimed once it has passed. In contrast, certain ancient philosophies and even some modern scientific theories propose that time might be cyclical, repeating itself in endless loops, much like the familiar return of the seasons. This challenges you to imagine a reality where time is not an arrow aimed at the future, but an eternal, recurring pattern. This inquiry into time's nature also leads us to contemplate our origins. If the universe and time itself began with the Big Bang, what does that imply about our sense of the past? Is it even logical to ask what came before that singular event? Many scientists contend that because time as we know it may have been created in that moment, the question is inherently meaningless. This perspective opens up staggering questions about concepts like eternity and the infinite. Another compelling idea that has been debated for centuries is that time might be a purely human invention. Have we simply created this framework as a tool to organize our experiences, or does time possess an objective reality, independent of our perception? Some philosophical schools of thought even propose that time is an illusion, something our minds construct differently based on context and personal experience, a notion that compels you to question the very fabric of reality. Furthermore, the link between time and human consciousness is a rich field of exploration. Our internal perception of time's passage profoundly shapes our life experiences. Psychological studies have demonstrated that our emotional state can warp this perception. For instance, joyful moments often seem to fly by, whereas periods of suffering can feel agonizingly slow. This subjectivity reveals that while time may be a constant force in the universe, your relationship with it is deeply personal and ever-changing. Our understanding of time also has profound philosophical consequences for how we confront mortality. If time is finite, and your own existence is but a brief interval within its immense expanse, how does that knowledge shape your view of life? The prospect of death can be terrifying, yet it can also be understood as a necessary and natural part of time's endless cycle. Many philosophers argue that embracing the finitude of our time here enables us to appreciate each passing moment with greater depth and live with more purpose. In the ongoing effort to comprehend time, the realms of science and philosophy frequently overlap. Modern physics, particularly through the lenses of relativity and quantum mechanics, has completely transformed our understanding. Einstein's theory of relativity revealed that time is not a rigid, absolute constant, but a flexible dimension that can be warped by gravity and velocity. This concept dismantles the traditional view, presenting time instead as a dynamic fabric that is intricately woven together with space and matter. It's also fascinating to consider the paradoxes that emerge from contemplating time. The idea of traveling through time has long been a staple of science fiction, but could such journeys ever be physically possible? Theoretical concepts like wormholes and parallel universes hint at a multitude of possibilities, Yet they also bring up complex questions about the ramifications of altering the past. If you could travel backward, would you be capable of changing history, or does the timeline have an innate mechanism to correct any such disruptions?
As you reflect on the nature of time, you inevitably encounter the central role of memory. Your memories are the very foundation of how you perceive time's passage, connecting you to your identity and providing a framework for your experiences. But what is the impact of our imperfect or distorted recollections? The way you remember an event can powerfully influence your perception, making certain moments in your past feel much closer or more distant than they truly are. Ultimately, time serves as a mirror that reflects our own existence, compelling us to question our reality and to explore the essence of being human. Whether approached through scientific theory or philosophical inquiry, the study of time is an invitation to look inward. In the end, your experience of time is a deeply personal journey, a unique path that each of us travels in our own individual way. These philosophical implications challenge not only your comprehension of time's nature, but also your sense of place in the cosmos. If time is indeed a construct, what part do you play in its ceaseless progression? Are you simply meant to push forward, or is there profound value in looking back and reflecting on the past? These questions encourage an exploration of the bond between your own life and the vast universe surrounding you, serving as a reminder that time is both a profound mystery and a precious gift. In conclusion, this reflection on time and its properties becomes a journey of self-discovery, challenging you to consider how you lead your life and comprehend your position in the universe. Time can be either an ally or an adversary in your search for meaning, and how you choose to engage with it may define not just your individual experience, but our collective understanding of what it is to exist. Have you ever considered if time itself might have an end? Our perception of past, present, and future is inextricably tied to the existence of our cosmos, raising the question of what would happen if the universe as we know it were to fundamentally change, or even cease to be. The relentless expansion of the universe, propelled by dark energy, raises profound questions about the future evolution of time itself. This cosmic growth forces us to contemplate what lies ahead. If the universe keeps expanding, does that imply time will also stretch? Picture an inflating balloon, where points on its surface continuously move apart. Similarly, galaxies and cosmic events drift away from each other, potentially altering our very perception of time's passage. However, will this process be a slow, gradual transformation, or is there a point where everything will grind to a halt? One of the most compelling theories about the universe's ultimate fate is the Big Freeze. This hypothesis proposes that if expansion continues unchecked, all stars will eventually exhaust their fuel, plunging the cosmos into a cold, dark emptiness, where time itself might become meaningless. What then would that mean for you and me, conscious beings defined by our experience of time? Conversely, another possibility is the Big Crunch scenario. This theory suggests that gravity could one day overpower the universe's expansion, causing everything to collapse back upon itself. Such a collapse might culminate in a singularity, an event remarkably similar to the Big Bang, where space and time as we comprehend them could be reborn. This raises the question of whether time is cyclical, trapping us in an unending loop of cosmic creation and destruction. Now, consider an even more mind-bending idea: eternal inflation, a process where our expanding universe continuously spawns new universes. This theory suggests that somewhere out there, new cosmic realms are constantly materializing, each with its own unique reality and perhaps even its own distinct dimensions of time. Could you be living within a vast multiverse,
a hypothetical collection of all possible universes where the rules of time are different in each one.
Theories about the universe's future also force us to confront the principle of entropy, the inherent tendency for any system to move from a state of order to one of disorder. As the cosmos continues to age and entropy steadily increases, how will this fundamental law impact our experience of time? If the arrow of time points toward ever-increasing chaos, can we still hope to find meaning in such a future? Each of these cosmological scenarios challenges you to rethink the very definition of time. Is it a straight, unyielding line moving ever forward? Or is it more akin to a complex loop with countless branching pathways? This line of inquiry leads us to consider whether time is fundamentally a human construct, a framework we developed to impose order and meaning upon our own existence. The deep connection between the cosmos and time also brings up questions about our own place in the universe. If both time and the universe are fated to transform or even vanish entirely, what does that imply for the legacy of humanity? In a future that may become an immense, featureless void, how will subsequent generations, if any exist, remember our civilization? The quest for these answers is an integral part of the human journey, a journey that evolves as our exploration of the cosmos deepens. While physics and cosmology offer powerful tools for understanding time on a universal scale, it's vital to recognize that science and philosophy are intertwined in this pursuit. The uncertainty of the future encourages us to reflect not just on time, but on how our actions today might ripple through an expanding universe, reminding us that every decision carries weight. Ultimately, contemplating the destiny of time and the universe brings forth a question that strikes at the core of our consciousness. In a cosmos defined by constant change, how do you want your legacy to be perceived? The potential answers are as varied as the universe itself, but they all converge on a single truth, that every moment is significant. It is our effort to understand time and our place within this grand cosmic theater that ultimately gives our lives meaning. To truly grasp the idea that time may have started with the Big Bang, you need to take a step back and view the larger picture. Think of the Big Bang not merely as a cosmic explosion, but as the very event that ignited the universe, marking the inception of space and time as we know them. It created the framework for everything that followed. This raises a question that seems simple but is profoundly complex. Could time have existed before the Big Bang? If time itself began at that moment, then the concept of a before becomes logically incoherent. It's like asking what comes before the first page of a book. There is simply no preceding content to reference, as the narrative starts from that point. Finally, you must consider the initial singularity, the theoretical point where all the mass and energy of the universe were compressed into an infinitely dense state. This singularity represents one of the greatest unsolved puzzles in cosmology. It not only defies our current understanding of physics, but also raises fundamental questions about how time could have possibly functioned at the very dawn of creation. When you think about time, you might picture an ever-flowing river, both constant and unstoppable. But what if I were to suggest that this river might have begun its course at a very specific point, the very moment of the Big Bang? This event, which we consider the start of everything we can observe, forces us to question what could have existed before it. Was time an actual phenomenon prior to the Big Bang? Or was it just an idea without any relevance in that initial singularity? The notion that time itself was born with the Big Bang is both fascinating and profoundly unsettling. If time truly is a property that emerged from that singular moment, it implies that the past as we understand it simply didn't exist.
Trying to imagine a universe devoid of time is a genuine challenge for our minds, which are so deeply conditioned to operate within the framework of past, present, and future. Yet, scientific understanding suggests that time, as we experience it, is fundamentally interwoven with the fabric of the cosmos. Since both space and time apparently originated from this singularity, does it follow that time itself behaves differently under such extreme conditions? This concept is tied directly to the expansion of our universe, which demonstrates that space is not a static backdrop, but is instead perpetually stretching, much like an inflating balloon. As galaxies drift further apart from one another, we are left to wonder what this cosmic expansion implies for our own perception of time. Einstein's theory of relativity adds another profound layer of complexity to how we comprehend time. According to his ideas, time is not a universal constant. It can actually stretch and compress in response to gravity. This means that time passes more slowly in environments with intense gravitational fields compared to those with weaker ones. Consider this. If you were on a train traveling near the speed of light, your sense of time would feel perfectly normal. But to a stationary observer, your time would appear to slow down dramatically. This very idea, that time is relative, compels us to reconsider what we truly mean by the word now. The arrow of time presents another fascinating puzzle, as it seems to describe the unidirectional flow in which time moves. This is often linked to the concept of entropy, or disorder, which consistently increases throughout the universe, pushing events from a state of order toward chaos. This universal tendency strongly suggests that time possesses a distinct direction, but the underlying reason for this remains a topic of deep inquiry, possibly connected to our interaction with the universe and the evolution of physical laws around us. From the viewpoint of quantum mechanics, the nature of time becomes even more bewildering. In the quantum realm, events lack the predictability found in classical physics. Particles can seemingly exist in multiple states at once, creating paradoxes that defy our conventional understanding of a linear timeline. Is it possible that, at the quantum level, time isn't a straight line at all? You might envision it more like a river that forks into numerous different streams. In the field of modern cosmology, scientists are grappling with fundamental questions about time's nature within an expanding universe. As the cosmos continues to grow, could it be that we are only witnessing a small fraction of something far grander? The possibility that time functions differently in other regions of the universe forces us to challenge our own assumptions about temporality itself. As we delve into the essence of time, we discover that science and philosophy provide distinct yet complementary viewpoints. Science pursues answers through empirical observation and experimentation, whereas philosophy encourages us to contemplate what time signifies in the context of our own existence. Experiments that push the boundaries of our comprehension, like the famous double-slit experiment, remind us that science does not hold all the answers, and each new discovery only opens up more questions. Different cultures and ancient mythologies have also offered their own unique explorations into the concept of time. These narratives, ranging from ideas of eternal cycles to linear progressions, present a rich tapestry of interpretations regarding time's origin and meaning. In the end, every culture contributes a valuable piece to the puzzle, helping us construct a more holistic understanding of what time truly is. Astronomers treat the Big Bang as the foundational point for charting the history of the cosmos. Every star and galaxy you see in the night sky is a remnant of this distant past, an echo of what once was. This begs the question, what future breakthroughs might unveil even more about time and the universe? As our technological tools and scientific methods advance, we are likely to uncover answers to questions that seem utterly unapproachable today. Finally, we must also acknowledge the alternative theories to the Big Bang that push us to think beyond conventional models. Concepts like the steady-state theory or the cyclic universe challenge the dominant narrative, prompting us to consider that there might be more than one plausible story about the genesis of our universe and of time itself. Each alternative offers a fresh lens through which to examine these profound mysteries. In conclusion, time is a deeply multifaceted phenomenon that weaves through science, philosophy, and culture. Every concept we have touched upon provides a new perspective for thinking about time and its intricate relationship with the Big Bang. As we persist in our quest for definitive answers, one thing becomes clear. Time will likely always remain an enigma that beckons us to continue exploring, with the search itself being what fuels our deep-seated desire to comprehend the universe we inhabit. The enigma of time deepens considerably when you view it through the lens of quantum mechanics. Within this domain, conventional laws no longer apply, and paradoxes are commonplace. Quantum theory directly confronts our traditional understanding, raising questions about whether time is a smooth, continuous flow, or a sequence of individual, distinct moments. It suggests that on the most fundamental scale, the linear progression you experience might not be the complete picture. Venturing into the era before the Big Bang leads us into the territory of pure speculation, where some scientists theorize about the existence of a completely different form of time, or perhaps a state where time itself was meaningless. This prompts a deeper philosophical question. What if our very concept of time is simply a construct, a framework our minds have developed to make sense of the world? Throughout history, diverse cultures and myths have offered their own interpretations, from the cyclical patterns of nature to grand creation stories, weaving time into the very fabric of their search for meaning. With every advance in cosmology, fresh inquiries arise concerning the nature of time within our expanding universe, forcing us to ask how this cosmic inflation influences our own perception of its passage. While each discovery brings you a step closer to solving the universe's great puzzles, it also highlights the immense scale of what remains unknown. Consider that the ultimate fate of the cosmos is yet to be determined, and its evolution could fundamentally reshape our comprehension of time, posing questions about whether it will have an end or transform into something entirely different. Ultimately, time continues to be one of science's most profound mysteries, from the initial singularity of the Big Bang to the bewildering principles of the quantum world. Every breakthrough only seems to add another layer of complexity to our knowledge. In its very essence, time serves as a powerful reminder that the pursuit of understanding is an infinite journey, where each answer you find simply unlocks a new set of questions waiting to be explored. So, did time truly begin with the Big Bang? A straightforward answer may forever elude us, but what is certain is that this very question serves as a powerful catalyst for human curiosity. It marks a point where science and philosophy merge, weaving a rich tapestry of thought that pushes you to look beyond conventional explanations. The real beauty of this quest may not lie in finding a final solution, but in the unending process of investigating, questioning, and marveling at the vastness of the cosmos. An endeavor that is far more than a scientific problem, but an open invitation to stay curious.